All right, today's story has everything to do with this. This is a nightlight. It plugs into an outlet. It has a light sensitive resistor, and it also has an LED light in here. The idea is when it gets dark, the resistance of this goes up. It activates this LED in here, and you get a little bit of light so you can see where you're going. So what would happen if you took that light and shone it right there on that resistor? It would get dark, the light would come on, the light would hit this, and the resistance would go back down, the light would go out, and so forth and so on. And you'd end up with this on, off, on, off, on, off kind of action. So can we use that to our benefit? Well, as a matter of fact, we can. We can use this behavior to do some very cool things. This is a compressor made from a nightlight just like this, and when the audio signal comes in, it, depending on how loud the signal is, it lights up an LED, and then that's used to affect the photoresistor, which then tweaks the gain for the output. So if it's loud, it turns it down. If it's soft, it turns it up. Now we can also use that same action for this effect. This is a vibrato or tremolo. Essentially what it is, it's a clock that lives in here, and it's sending out this low frequency oscillator, and it sends out this undulating voltage, which is used to drive an LED, which drives the photoresistor. So instead of working from the loudness of the guitar signal, it's working from that low frequency oscillator, and it pulsates, and it sounds retro. It sounds very surf. Anyway, but there's some other things that I've also identified that can do some very similar things. First up, we have this compressor that I got from Amazon. It at most cost about $20, and it sounds similar to this. In my opinion, this feels a little bit more limited trying to run through it, so that's another one. In the early days of radio, sportscasters would call out a game using a compressor like this. So if the game was boring, he would speak in a soft voice, and it would amplify him so you could hear him over the airwaves. And if the game was really exciting, like somebody scores or there's a really good play, he would yell with excitement, because that's what you do in a sports game, and the compressor would bring that voice level back down. Now, this isn't for calling out a game or anything like that, but this is a wireless system for a guitar, and then it gets picked up at the receiver end and it goes to an amplifier. So it works, but just because it's a set of radios here, the transmission does tend to be compressed, and you can feel it, or you can hear it as you play. Let's hook up a test harness and give these a listen. All right, first up on the bench, we've got the compressor with its three controls. We've got gain, compression, and sensitivity. Sensitivity controls the amount of current coming in to fill up that capacitor, which then drains through an LED, and that drain amount is controlled by compression. Gain is the part that gives us some sacrificial gain that the compressor will eat up here. So you can see my controls on this other camera. That's my dry signal, no effect. I can pick soft, or I can strum loud, or strum soft. All right. With the compressor on, I'm hitting that pretty hard. All right, so dialing this in, let's see, give it a little bit of gain, do the sensitivity and the compression all the way up. All right, there's that point right there where it starts to go too quiet. So now I've got nothing. I turn down the sensitivity, so that lets a little bit more current through. And there's this kind of magic spot where it does okay. Turn it back up again. Now you may notice that's too far, because what happens is you can't hear the initial strum and then it relaxes into it. So let's turn that down a little bit and give us a little bit more wiggle room. And that's not too bad right there. All right, let's try another compressor on here. Let's try the store-bought one and compare notes. So this one's got a few more controls. Let's see, we've got a tone, we've got a normal and treble, and a volume, and then this mysterious knob here, which doesn't really seem to do anything. Okay, dry signal. With it on. And it sounds okay. If I turn this up, it's like breathing out in the middle. You can really tell on those sort of snappy notes. So in my opinion, this seems like it either doesn't do enough or it's eating a little bit too much of that initial punch that the note should have. So it's, I don't know, it's just not as useful to me. All right, let's try something else. All right, for this test, we have a transmitter and receiver. And for this one, we're just going to use the effects loop pedal here. I'm going to receive on this end, and we're going to transmit on this end. As a transmit and receiver, it's cool that you can play. This is really designed to go into the guitar, then into the amp or whatever. And so you can play wirelessly and throw the guitar around and be a gymnast and all that kind of cool stuff, or not. Here we're using it just to, let's see, into the transmitter. There's a little bit of a compression that happens. It gets transmit over to the receiver and it turns it back into an audio signal. It's not that loud. soft strum. And building up. So in my opinion, this actually works better as a compressor. Even though it's not adjustable, it works better than this cheap compressor because I don't know, it just sounds a little bit more natural coming through here. Now there's like zero flexibility in it. So there you have it. You've got the three different compressors. You've got the optical one that we made. You've got this one that's store-bought, and then you've got this one, which is kind of a neat thing to do with a wireless guitar transmitter and receiver. All right, let's look at our last example. Okay, now we've got the tremolo effect in the loop. Dry signal on the green. Go over to the loop. Now the key difference between the compressor and the tremolo effect, it really is the same circuit on this upper part, but instead of having the level of that input signal coming in to drive the LED, what we have in here is Optocoupler, which has been configured as a low frequency oscillator. So we have the rate control by the amount of juice coming into the LED, and then we also have power coming into the LED part of the opto isolator, and it's draining through this phototransistor and this meaty capacitor right here. It's controlling the peaks and valleys of our low frequency oscillator. So meanwhile, back to this guy. I find this works better just putting the gain all the way up, and then I have the speed control that it has this usable range. So right about there at the 1 o'clock position, it starts to lose its oomph. So I have to turn that up a little bit. There we go. That's the slow. And turning the speed up. So there's not much in terms of the usable speed. This goes from about 1 o'clock to 3 o'clock, from the slowest to the fastest speed. If I made this again, I would make a change there and try to get that resistance value into a more usable range. So, and there's ways to do that, but that project is for another day. All right, thank you, people. I appreciate y'all hanging through that. That was a long one, but I had a lot of stuff to cover. If you're digging this stuff, do me a favor and head on over to Amazon. Leave a review if you've already got the book, or consider getting a copy of the Cigar Box Guitar Amplifier Notebook. It's got all these circuits and some other ones that are coming up next. All right, thanks, guys.